Hello there, and welcome to today's video on evaluating a definite integral from 1 to 4 of 3 over x to the 4th dx. Now remember, to evaluate a definite integral, we can use the fundamental theorem of calculus if our function is continuous on the closed interval. And if I'm evaluating the definite integral from a to b of f of x dx, the fundamental theorem says if you find an antiderivative for your integrand, then you can find the definite integral value by evaluating that antiderivative at the upper limit of integration minus that antiderivative evaluated at the lower limit of integration. So the first thing we want to do is to find our capital F of x, our antiderivative that we're going to use. And to find that, we find the indefinite integral of 3 over x to the 4th dx. Remember, to find this indefinite integral, we need to first write it so that I don't have the division of the x to the 4th. So we're going to write this as the integral 3 times x to the negative 4 dx. Using the constant multiple rule, we will bring the constant factor of 3 out in front of the integral. And then we notice that we have letter base to number exponent, and the number exponent is not negative 1. So I'll use the general power rule to integrate that expression. So I have 3 times. General power rule is keep your base of x, add 1 to the exponent, negative 4 plus 1 is negative 3, and then divide by that number, that negative 3. And remember to add your arbitrary constant. Simplifying this gives me a negative x to the negative 3 plus c, and then rewriting it without negative exponents gives me a negative 1 over x to the 3 plus c. And because with the fundamental theorem of calculus I can use an antiderivative of small case f of x, it can be any antiderivative of it. I can choose the antiderivative where c is equal to 0. So antiderivative we're going to use is f of x is equal to negative 1 over x to the 3rd. Bringing that over to our work then with our definite integral from 1 to 4 of 3 over x to the 4th dx, we are going to have our f of x evaluated at our upper limit of integration, and then subtract from that our antiderivative evaluated at the lower limit of integration. So we start with our negative 1 over, plug in the upper limit of integration, and subtract from that, from the fundamental theorem of calculus, a negative 1 over, now plug in the lower limit of integration. So this gives us negative 1 over 64, and then minus negative is plus, and then 1 cubed is 1, and 1 divided by 1 is 1. And taking negative 1 over 64 plus 1 gives me 63 over 64 as the value of my definite integral.